My name's Ian McDonald. I'm the director of the Tallwood Design Institute. We've been running these meetup events for quite a few years now, and I think we're coming up on almost 50 of these. We started to do these in person back in Portland a few years ago. The the pandemic kind of moved us online, and then we've kind of bobbed back and forth doing the occasional in-person event in Portland and other places, sometimes on our OSU campus in Corvallis, Oregon, but generally online as well. And really, TDI is interdisciplinary applied research and education collaboration between Oregon State University and University of Oregon. Um, my colleague Judith Shine is on this call. She's the lead on the Tallwood Design Institute from the University of Oregon side, and she just clicked on her camera. Hi, Judith. And also the person that really put this together in terms of promoting Parker Ackerman, our marketing communications coordinator. So thanks, Parker, for all your work. And I'm just going to turn it over to Dylan Wood, who's assistant professor at University of Oregon.
Okay, it's
and I will let you take it from here, Dylan, and introduce the panel.
Okay, awesome. Thanks a lot, Ian, for introducing Tallwood and for arranging these sessions. I think I have not been to one yet, but I'm sure that there's a really interesting audience and we can have a great discussion. Today's meetup, or this month's meetup, is going to focus on automation and robotics for timber architecture and building construction. And I'm really happy to have a couple of former colleagues and also new partners that we're working with now, joining from around the world to sort of give us some insights into these areas that I think are sort of probably rather futuristic looking, or let's say at the edge of the near future in terms of industry, but also giving us a lot of insight as we sort of look at how mass timber is, in my opinion, definitely going to scale and grow, specifically in the Pacific Northwest. We're going to have 3 presentations today. And then we will have a discussion. We should have plenty of time for discussion. We do have a small change in the schedule, and so we won't be having a talk from Jills and Molly from AUR, Automated Architecture in London, but we're really lucky to also have now Aaron Anderson here from Swinerton. And so I'll introduce the speakers sort of as we go through, and then we'll try to keep the questions and discussion before the end. And if you have specific questions, I think you should, or points, you should be able to also post these in the chat. So let's reserve the chat for questions that you want to add to the discussion. So we're going to start with Hans Jakob Wagner, who is the research group leader and PhD researcher in the Institute for Computational Design and Instruction. It's led by Professor Achim Menges at the University of Stuttgart. Jakob was also my colleague for a number of years and former student. And I think we're really excited to see how his work has sort of progressed through that, and I think we will get this sort of hint as to how robotics are working in an institutional research setting. So with that, I think we can start. Jakob, we should be able to share the screen.
Sure, great. Thanks, Dylan, for the nice introduction. I'll try to share the screen. Yeah, so hello everyone. For me, this is a slightly later evening gig today, but I'm really happy to be here, and I will try to give a very energetic presentation. I think Dylan already mentioned. Basically, Oliver, Dylan, and me were both, at least for some months, at the same time in the ICT here in Stuttgart. I was back when Oliver was still there. I was just starting. That was now almost 7 years ago, I think. Since then, quite a few things have happened. So I'm really happy to kind of share what we've been doing and also to follow up on what is going on everywhere else. So I'll speak about adaptive automation in computational wood architecture. And that is basically one of the core focus topics that we're trying to address in my research group, aptly called Computational Wood Architecture, with a small twink at Oliver. And what we focus on is the kind of development and the conception of digital building systems. And at the same time, we try to integrate that with robotic construction processes. On the digital building system side, we've been focusing mostly on long-span timber structures, but since now more than 5 years, we've been deeply invested in multi-story building systems. And on the robotic fabrication side, we've been doing mostly robotic prefabrication. But since recently, we also focus on, we have a big team together with our partner institutes here at the University of Stuttgart, where we develop novel robotic on-site construction processes. We do that all under the notion of co-design, where we try to integratively develop design and engineering methods together with fabrication and construction processes, and develop new building and material systems. Fairly good example for that is the Buga Wood Pavilion that is depicted in this bubbles here, where we came up with a new building system. Actually, that was mostly still when Oliver was here, and then we developed a new fabrication process together with a new fabrication platform in that case. And I'll show quickly how that looked. Basically, we had a robotic fabrication cell that we transported to our partner at Müller-Blaustein Construction. And these two robots were basically taking directly the data from a computational design model to assemble 376 unique cassette building assemblies. And after fabricating those, this is the final result. We were able to assemble them on site with basically zero tolerance, speaking to the high accuracy that we can achieve with robotic fabrication. And even though each of those building components has a unique shape, the robotic fabrication was fully automated. And this is basically the starting point of what I wanted to present today, because these kind of projects, the segmented timber shells, were really a great vehicle to communicate what is possible and what we can achieve, what kind of novel forms and novel design opportunities we can find in the combination of novel technologies of computational design coupled with robotic fabrication or digital fabrication for that matter. But of course, we all know that not all buildings must be segmented timber shells. Some buildings sometimes are also multi-story structures. And we, after the Buga shell, we basically ask ourselves, okay, how can we apply those technologies and those kind of concepts and this kind of fundamental method of co-design, of integrative development, how can we apply this to multi-story structures, and how can we avoid or overcome a certain kind of limitation that has been in construction visible since like at least 100 years. We've seen the systematic kind of functional and standardized prefabricated buildings from the 20th century, and our hypothesis or our research challenge is that even though today we speak about kind of standardized and prefabricated construction with completely new terminology, we need to be very careful not to fall into the same kind of traps that have become apparent with the standardized systems of the 20th century. I think Oliver's company is a really nice example of trying to overcome those kind of constraints that kind of lead to a fairly strict and fairly kind of non-adaptive and rigid kind of architecture. And in research, we're trying to power this kind of movement of overcoming these kind of restrictions. And what that means is that we want to achieve in timber construction a similar kind of spatial experience that is possible with concrete slabs. Specifically, I'm talking about slabs. For that, we need, of course, to transfer a kind of unidirectional material that is timber with its kind of predominant fiber directionality and anisotropic kind of material makeup. We need to achieve not only a bidirectional kind of plate and slab structure, but we need to achieve a truly multidirectional slab structure. And that's really the challenge that we're trying to solve. That's a challenge of not only material buildup and cross-section, it's of course also a challenge of joints and connections. But the overall goal is to achieve building spaces like you see here now on the screen. I guess far less exciting and crazy as let's say some of the other projects that we're doing in ICD, but really truly meaningful to me, because I really believe that if we enable timber construction, this kind of freedom of less rigid kind of ordering systems for the buildings that we do with them, then they can achieve really also a much higher market share for that matter. And what did we do? We applied.
Hey, Connor. How are you?
We applied the same method as I mentioned before, called co-design, and we basically developed a new, fundamentally new building system from scratch. Actually, Oliver still had his fingers in that project as well. Gonna skip slide quickly. So early 2018, 17, I guess, there was already the first research project application with some ideas on how multi-story timber structures could evolve and how they could become more adaptive, more performative. In 2019, I started working on that with the first kind of prototypes, and since then we've been on a fairly amazing journey. We've worked together with fantastic engineers at the MPA here in Stuttgart, with fantastic building physicists, acoustic engineers, and of course our colleagues at the Institute for Structural Engineering at the ITKE with Professor Knippers. And we've built prototypes together with Züblin, which is a large construction company here in Germany, and tested our robotic fabrication and and also did already some first tests on the robotic on-site construction, where I can only show some very, very early kind of hints on how that's gonna look. And at the same time, we implemented this new system into the design of a new building that we're currently planning, which is the L0L, or the INCDC building. The INCDC is the excellence cluster here at the University of Stuttgart, basically a large research center. And the building that we're envisioning will become the laboratory for that cluster. And our multi-story timber slab structures are located here in the office area of that building. And I will quickly introduce you now on the concept of that building system. Basically, we start with a CLT slab, but we make it hollow. We split it into two plates, have a hollow core, and we couple that system with shear webs, and the system is point supported, so that those shear webs actually necessarily need to follow the force flow in the structure, and around the column we reinforce the slab with solid blocks. We split the slab in segments that are fully robotically fabricated. We use a glued manufacturing process, so basically the elements are glued onto the bottom plate first, and then the top plate is glued onto those inner beams. Of course, the size of the segments needs to follow the kind of fabrication space of the robotic fabrication setup, and then we have all those segments joined together to form a quasi-monolithic slab structure on site. Of course, there's different forces in different regions that not necessarily follow the same segmentation pattern that fits the structural logic, the fabrication logic. So we have actually a number of different kind of joints that follow a different kind of performance spectrum implemented in those structures. And really the core aim is that we allow a complete flexibility to the architectural designer to put columns wherever they want in the building, and to then have the building not be dictated by the transportation limitations of certain segments and by the transportation logics of modular construction, but really the fabrication domain and the fabrication limitation at some point just disappears in a solid flat slab, independent of where the columns actually are positioned. At the same time, that allows us to build highly adaptive buildings, which is specifically important in inner urban developments, where the sites sometimes have their own quirks and boundary constraints, and at the same time have also internal constraints that come from mixed use development. So maybe there should be a supermarket on the ground floors, then some offices in the first upper floors, and then some residential units on the top floor. Each of those systems have different kind of requirements on column positionings and kind of grids. So actually those buildings usually, if you build them from concrete, are done with fairly large spans, and of course are point supported, so that they can also be reused very adaptively. And we try to achieve the same thing with timber, and importantly without beams underneath, so that we can actually achieve also very compact buildings, and we don't lose very valuable space inside inner urban developments. the building that we designed for the site here in Stuttgart tries to showcase all of those qualities. So it has 11-meter spans. It has like irregular column positions and a cutout for a central stair that kind of connects together all of the office area. At the same time, we have a scissor kind of movement of the two slabs to really connect the office space with the hall and create this kind of bidirectional relationship between the researchers that are working on the computer and the researchers that are working in the hall with the robot. Yeah, that's kind of where we are. We hope to finish that building fairly soon. We're currently waiting for the final signatures of the client. You can imagine it's a big project and quite exciting to us to start the fabrication together with Züblin Timber. I'm actually coming to the end of the presentation. I just wanted to give a very short outlook to some new projects that are starting in parallel to the project that we just saw, which is a new slabs system which completely breaks free from the logic of prefabricated CLT plates, but much rather we want to build here our segments starting from the lamella itself, following some of the insights that we gained with the hollow building system that I just showed. And this project is interesting, and I mention it also specifically because it's actually a transfer project funded by the European Innovation Council. So within 2-3 years, there's really the hope that we can push this technology to the industry. So if you're interested, just hit me up and contact me. I would be super happy to include you onto our mailing list and keep you updated on the progress on that project. Also feel free to follow us at ICD Stuttgart, or you can also follow myself on LinkedIn and on Instagram under the handle Jakob. Thank you so much. I hope I was not too long.
Okay, thanks a lot, Jakob. That was really great and fantastic sort of overview from sort of product to system and manufacturing method and possibly the building and design. I'm sure there'll be many questions, but I think we will move now quickly to Oliver David Krieg. Oliver is the CTO of Intelligent Cities, which is a startup company. Okay, thanks a lot, Jakob. That was really great and fantastic sort of overview from sort of product to system and manufacturing method and possibly the building and design. I'm sure there'll be many questions, but I think we will move now quickly to Oliver David Krieg. Oliver is the CTO of Intelligent Cities, which is a startup company in Vancouver, Canada, and also a graduate or alumni of the Institute for Computational Design and Construction in Stuttgart. And we also had the pleasure of working together in a couple of different scenarios. And so I think it'll be great to see what you guys have, and I think also some very recently completed projects, which are great to see. So Oliver, the floor is yours.
Thank you, Dylan. Thank you for the invitation. Good to see you all again. I was here, I believe, 3 years ago or 4 years ago when Intelligent City was truly a startup. I think we are now a scale-up, as per the definition, but definitely still in a early process of a lot of R&D and engineering as we are also delivering our first projects. It's really great to see. I need to comment on ICD's and Jakob's progress towards more applicable systems I think it was never the intention for ICT or any of the projects to be immediately applied in industry. There is a really big value in having the academic freedom of exploring different technologies and concepts, even without necessarily having them economically viable from the beginning. But it is always important, I think, to look at both aspects, performance and economics. Truly, when you try to develop a platform, if you want to call it that, for construction, a platform for buildings that you can replicate, that you can customize and configure, it always comes down to the finances of the project, the finances of the construction, and the value that you create. But I think so it's great to see many different ideas and different approaches to that, and different degrees of business ideas. I would say. So just a long introduction. I am an alumni of ICT as well. I did a PhD in robotics and timber construction. Intelligent City, for those of you who don't know, we deliver housing with a product platform approach, which means that we have developed and are still developing systems, basically building platforms that allow us to manufacture them at scale and deliver with consistency, but a high level of customization. That means we standardize processes, we systematize the delivery of buildings, but we adopt principles of mass customization through the power of technology by defining design ranges or design spaces of our building systems, and ultimately encoding them in our design systems, which we then can automate using software and basically connect the complete supply chain or value chain of building buildings from design to manufacturing and into construction. I do not need to tell you that we have an industry that is responsible for a very large portion of global greenhouse gas emissions while having an extremely hard time innovating due to its fragmentation. I'd like to show this slide as well because it's a really good slide for Canada. We have an incredible need for housing. We have an incredible amount of resource to do so, and yet construction is extremely tedious, fragmented, and really difficult to control. Although a lot of the buildings largely look the same. So the idea of a product platform is obviously not a very new one, also not in construction. But maybe to make a point here as to why it may be so difficult to implement. A product platform is a set of common repeatable elements that can be shared across a range of related products. A really good example is the kitchen. A kitchen is actually an industry-wide product platform. Every kitchen supplier has agreed to adhere to certain constraints so that they're interchangeable. And so you have basically everything is based on certain base cabinets and variations thereof. And there are standardized interfaces so that you can buy different fridges and stoves that can interface with your kitchen. So ultimately, each kitchen can be different, even though it is sharing common parts. Other great examples of product platforms are cars, obviously. Lego often comes up. I really like the tension when we compare with the car industry because there are so many good lessons we can learn from it, and yet there are so many things that are not applicable to construction. The number one thing being you cannot do this. You cannot vary the length and the width of your car because your garage is wider or longer and you want to utilize the space that you have in your garage, right? That sounds maybe familiar for those of you who work in real estate development. If you have a lot that has a certain size, the building has to fit in the lot. And so what we encounter when we look at multifamily, especially multifamily construction, is that the configuration of the building is one aspect, but the other aspect is also what actually fits on the size. And so we have to combine the idea of a product platform, the idea of having core elements, complementary elements, with the idea of geometric adaptation or geometric customization so that the building fits on size onto the site. So what we did in Tauschen City is we like to design the entire building, deliver the entire building as architects, in the future also including the engineering, although some of that is already in-house. We manufacture and are specifically focused on the core elements, which is the envelope and the structure of the building. And then we interface with complementary elements, and we are trying to build an ecosystem here with prefab bathrooms, interiors, balconies, and other parts that attach to the building, so that we end up with a product family that we usually divide up into basically low-rise, mid-rise, and high-rise construction. And from that, we can then deliver individual projects that can differ significantly in their shape, in their design, but they're still based on the same platform. So that's the ultimate goal of industrializing construction. And I'm sure we're not the only ones working on that. You develop a variable, configurable product platform from which you could deploy many different buildings. So ultimately, the design process of a building becomes a configuration process. You go for sort of from designing a project to configuring a product. So you ultimately start with the massing, you put in the apartments, you have a few choices in terms of performance. There may be some choices for the structure, but then ultimately it's really down to facade. You can see windows, cladding, materials and colors, accessories, and the interiors. So the combination of the very first part and the last part is really sort of what defines the aesthetic and the branding of a building. And these are the aspects that have to be really variable. And so for the last 6-7 years, we developed the technology suite in a way that would allow us eventually to design and deliver these buildings. It can be very easily divided up into 3 aspects that I want to talk about a little bit more in the next 10 minutes. The one part is are the building systems essentially. So really the floors, the superstructure, including the columns, the envelope system, both of them mass timber based, both of them made for high rise, both of them certified for prefab and enclosed spaces. We do have a portion of MEP integrated into those systems, but what isn't integrated is still planned within the system. So it's controlled by us. To deliver these, we had to develop manufacturing technologies, and we had to equip our own factory with tools that allow us to build or to manufacture these components in a certain level of variability. So very, very similar to what Jakob just showed, the design to manufacturing process, what kind of components can you make, what are your limitations in terms of design space coming out of the machines that you're using, but also, of course, transport and cost and so on. And ultimately, this is all controlled by a software stack that is really just a plugin in our case, plugins, tools that we develop ourselves in Rhino and in Revit that allow us to design a building, basically divided up also into 3 aspects here: Delta Studio to design the building, Delta Systems that populates the building parts into the building, and ultimately defines sort of the BIM model if you want. It's a very enriched model. It has a lot of manufacturing information, so that the translation then into manufacturing data with Delta Manufacture is then ultimately a very easy process where we simulate the production, export into the ERP system and so on. So how does that look like? In terms of building systems, it was really clear from the beginning that what is missing in this industry is an ecosystem of prefabricated components. Again, if you want to compare it to the car industry, there are many companies that prefab lights, seats, steering wheels, and so on. Same in other industries. You have suppliers and you have the OEMs. What's missing in our industry is a big supply chain for mass timber prefabricated components. And so we decided, at least for those aspects, we have to develop our own systems and we have to ultimately manufacture them ourselves. Basically, if you look at our buildings, they are made from floor cassettes, columns, and envelope panels. Very interestingly, maybe this one first here, our floor cassettes are indeed cassettes. They are hollow core, two-way spanning pressed skin floor cassettes. Very similar to what Jakob just showed. They have an interstitial space where ribs transfer the shear forces, and they allow us to construct buildings without supporting beams. At the same time, they also allow us to implement services. I'll show that in a second. The other part is a mass timber curtain wall envelope system that is applicable for high rise. So as far as we know, it's the first one of its kind. It is passive house certified, or can be passive house certified. It passed certification tests. And so that is sort of the first step. How do you lay out the structure of the building? It comes with a lot of constraints. That is really clear, especially in housing. You really overlay the structure with the apartment layout. So the apartments also become part of our library because they really define how we subdivide the building into grids. Not only because of the columns, but also because of what you see in the top right here, which is mechanical and electrical systems that go into the floor cassettes, and they obviously relate to the layout of the building. And so how we lay out those floor cassettes has become sort of really the cornerstone of our systems. You really start with the layout, core placement, and follow, I would say, relatively rigorous rules, although in mass timber construction, generally, these rules are a bit more rigorous than in concrete, where you have pretty much complete freedom. And that is also something that our industry is learning, that if you work with mass timber, if you work with systems built, you are a little bit more constrained in your design freedom. You cannot go completely crazy with your corridors and apartment layouts. But in turn, you get a system that is already resolved. In turn, you get a de-risked and accelerated project. So the value creation here is that you know what you're getting as a developer, and you know what it's going to cost, and it's not going to be an explorative process as traditional construction may be. Similarly, for the envelope system, it wraps around the building. It encounters all sorts of edge cases, such as corners, setbacks, balconies, terraces, parapets, and a combination of all of them. Again, it is a mass timber curtain wall system, so it's hanging from the structure, and it is approved for up to 18 stories in the construction. And this is a bit of a on the one hand, you get to understand how the system works. On the other hand, this is also the logic of our algorithms in the background, how they subdivide the envelope to enable us to put these panels in place. They're up to 2 grid spaces in size, so up to 28 feet. At that point, they do weigh around 5,000 pounds. So this has some significant implications also on on-site construction, what kind of crane you need to choose, and so on. We did test them twice actually already for passive house and seismic and all of these things, as we did test the floor cassettes for fire safety and structure and diaphragm performance. So a bit of a time frame here between 2019 and 2021 was early development. That's where we raised a seed round. In 2022, we got a factory space and put in some of our robot cells that we developed to kind of lay out the factory and the workflow of the factory to produce floor cassettes and envelope panels. And then throughout 2022, 2023, while we commissioned that and experimented with that, we got into our first project. This is a small 25 by 25 foot mock-up that we basically used as sort of the last chance to test everything, how everything comes together. And from there, we learned obviously a ton again of how these components come together on site. The goal is, to give you some metrics, the goal is at least 7 panels produced per week. That's 7 envelope panels and 7 floor cassettes. And the goal is also to install them every half hour to an hour, so that you can approximately, in a medium-sized building, you can install a floor in 1 or 2 days. And we've actually hit that recently in our current project that I'll show some pictures and videos of later. It's really down to the really small details of how these things come together on site, especially when you're up in the air on the 6th floor with a huge crane and it's a bit windy and rainy. That's when you can truly test if your ideas have worked. The manufacturing concept here is we automate those things that are difficult to handle as a person, as manual labor, but also those things that are repetitive, that need precision, and that need variation. So variability between parts is fine as long as people understand what to do, or as long as the robot knows what to do. So if every part that you encounter is different, but the manufacturing logic is the same, that's when customization becomes useful. And so we decided to implement robotics to assemble the components. We pick and place, we glue and screw. We also have our own robotic milling center. Let me see if I have some images here. So for, that is automated, has a little more automation than your traditional milling center, so that it's loading, unloading materials by itself. So we can ultimately implement it with AMRs, just as the one you saw in Jakob's presentation, so that the materials can be brought around the factory automatically. And then the same thing with the floor cassette, the assembly of, I'm not really showing a lot here because it's a very complex and sensitive process. But as you have seen before in the pictures, the floor cassettes glue together from various smaller components so that they form one consistent panel. Now that's all controlled through a software workflow. And okay, I'm gonna finish up here in a second. So as I mentioned before, we kind of structure it in 3 phases. You kind of go from the design intent to a BIM manufacturing model and ultimately to manufacturing data. I think this is probably the most important slide for this kind of idea. This is enabled by having a common data environment, so that all the objects that are generated in the first picture can be referenced to generate the parts that you see in the second picture, and those again can be referenced and manually edited or automated, depending on your workflow, to then be referenced again for the manufacturing information. And that allows us to basically create fabrication drawings, robot code, and so on, such as for the assembly of our floor cassettes, as shown here in the simulation, and ultimately for other parts. So we can see here we assemble the envelope panel with a robot, or at least the timber portion. A lot is still manual, of course, especially membraning and cladding install and so on. Although this is all up for grabs, we want to automate a lot more in the future. What you've seen here is a few months old. So we are just finishing up our first project. It is a bit more custom than what we would have liked, but it is actually a really beautiful cladding design with this sort of weave. You'll see a lot more of that around the building once the balconies and the screens are also completed. This is a 50-unit affordable housing project for BC Indigenous Housing Society here in Vancouver, BC. And it has a different structural system. We unfortunately came too late for this project, but we were able to provide the envelope, which really kickstarted our own commercialized production process in our factory. And we are now preparing, as we are finishing this project, we're now preparing actually the one in the middle here. It's a 9-story building that's completely intelligent city system that's going to go into production in December, and you will see it on site probably in April or May next year. So that's our second step. And with that, we are looking to expand. We actually see a lot of demand for repetitive housing that is really sort of the ideal candidate, you know, especially in the 7 to 12-story range in Toronto and generally the East Coast. And so we are currently planning to expand. Our current factory is really a very small plant. You would be surprised. It's just 15,000 square feet. It has a certain output capacity. We can do about 200 apartments a year. But what we're looking for is really basically a sort of a 5-fold increase, 75 to 100,000 square foot facility space, in which we then can produce between 1,000 and 1,500 apartments a year, both in BC and in Ontario, and then also in the US, depending on the demand. The really interesting, amazing thing is actually that mass timber really started a sort of alignment process in the building codes because of the adoption of the international building codes. And so a lot of similarities between building codes in throughout North America, with only minor differences that don't really affect our components as much as they simply affect the design of buildings and the setbacks and the apartment layouts. So that's where we are. I'll leave it at that. There's probably a lot more to discuss, but that gives you an overview of all the technologies that we have implemented so far and where we are as a company.
Okay, thanks a lot also, Oliver. That was really fantastic presentation, and it's amazing to see these things like going out into the wild successfully. And yeah, we hope that we are also sending some across the border. Okay, I think we'll quickly move on now then to Aaron Anderson. Aaron is the director of the R&D and innovation team at Swinerton, I believe. Correct me if I'm wrong. And he's going to share a bit more, I think, specific projects that and work that is happening with Swinerton related to mass timber.
Yeah.
Thanks,
Yeah, thank
Aaron.
you. Thanks, Dylan. And thanks everyone for sharing today and being here. It's really inspiring to see the future of the work. You know, at Swinerton, mass timber started out as basically a way to try to make these regular construction jobs more sustainable. And what we've really done is, like, instead of really starting from the theoretical side, we've started from ways to like really kind of go in and see a project that is that has already been planned for concrete construction or steel construction, and try to find a way to substitute mass timber into that space. And so oftentimes these shapes and things, you know, so that's really where a lot of our innovation and our process is coming from, is how to take this entirely unindustrialized process and then add, you know, layer in industrialization. So don't look at my calendar. No, I'm just kidding. You can see my calendar, but it's too full. So what, you know, what I really want to talk about today is, I'll hit on a few key things here, but really, you know, really for us, it's about finding what the most important parts are in the process to be able to layer in automation, to layer in robotics. And what we found is that waiting for detail is really the wrong answer. We try to get as much detail as early as possible into these into the process, and encourage people to get pencils down as fast as possible. So we create a really high level of detail in Revit. So we get to 450 LOD in Revit. We use numbering systems that make sense to folks. So we start numbering assemblies early. We get as much BIM information into those individual objects as possible, so that what we're giving people, what we're doing is creating that information that can be used throughout the process. In our actual production facilities, some of the things that we've really been focusing on are ways to use computer vision analytics. So instead of using them in the robotics, we're actually using them sort of to monitor the way that humans are interacting with our CNC machines. And then we've also been verticalizing in that space. So we now have traditional CLT manufacturing, traditional glulam manufacturing. And by having access to those facilities and those spaces, it's really giving us supply chain access and the opportunity to innovate in the supply chain. It's everything in these scenarios that we have an opportunity. A lot of things we have a lot of opportunities to innovate with some pretty available tools off the shelf. Like we can be looking at inventory automation. It's a pretty old-fashioned process of bringing 2x4s in on a truck. But if we can use computer vision tools, we can use other kinds of machine signals as these things are moving through the process, we get closer and closer to a faster, more real-time feedback on our processes. And then for us, a lot of the inefficiencies in the process and the risk in our process is actually once we get these products to the field. So these work packages that we develop, this level of detail, all those things are things that are really important that we're continually thinking about how to get to the field. So we've done a lot of stuff with automating, drawing production so that those things always have the same kinds of standards in them. They always have the information that's needed, and then getting the feedback from the field. So, early design assets with information really helps us to apply analytics early, extract information at different stages of the process, and then also more rapidly iterate for cost. When we get these Revit models connected to cost and schedule, we can rapidly iterate and see what the effect is going to be on the schedule. We never get more time and we never get more money when we get these prices up front. But by coming up with the detail early, so this is just an example of some of the drawing that we're doing, where we're even including screws, things like that early on in the LOD with the, and then also, getting a lot of an important information actually into the model. We think that the biggest reason why BIM has failed us in the past is because we're not actually getting the information in there. It's not coming in early. And so we're getting as much information that our fabrication facilities can use, our products, our ordering processes, all that, and we're keeping that as organized as early as possible. One of the big things I think that we forget in construction is that, or that we never learned in construction, is that, the reason why digital systems really work is that they rely on unique IDs. And so we're kind of going back to that as much as possible, where by getting assembly numbering and numbering done properly early, we're hoping that we even continue to connect those things into design intent and other aspects of the process. But we know that we have to have a comprehensive data model to make all this stuff work properly, and remove risk from the system and be able to systematically remove waste from the system. So, one of the things that we've been moving toward is finding ways to make our drawings live. The idea that we're using drawings is kind of a little bit ridiculous, but the reality is that everybody, the regulatory agencies, all these people still want drawings from us. And so some of the tools that we've been moving toward is really connecting those BIM models to drawing scenarios so that the two are lined up. We've found tools that allow us to not only connect the design to the field, but then also actually start attaching things like inspections, and all of these things specifically to these objects. So today we can go into the field, we can select a bunch of these objects, we can, do quality control forms, we can do all these things and tie them directly to objects instead of tie them to sheets or tie them to areas and things like that. The other thing that we've started doing in our facility is, we have a big, we still have a lot of labor in our processes. This is an example of our fabrication facility. On the right in this picture is our one of our CNC machines. We rely on the CNC machines to do most of our fabrication. And one of the automation flows that we use really is taking those high LOD drawings and then directly tying those, trying to find standard details that we can directly tie to already modularized G code or fabrication code. So that way we're able to much more quickly take certain types of beams and certain types of hangers and things like that, and already have the code written for them. It lets us scale up a lot faster. But then we've got this issue where we've got people and we've got these machines working together. And so what we started doing is really measuring these processes with computer vision by creating zones, setting up these objects, and just doing some simple things like time stamping them. What the time stamping has allowed us to do really is to dig really deep into our our process. And so we can look and dig down and see specifically how our load times versus our process times versus our unload times are on the table. Instead of in a day measuring that we had 12 pieces move through the process, we can actually see specifically how much time it took for each of those processes. And when you're working with people, what's important about that is also correlating the time spent in these places. A lot of times it's really underestimated the time we spend troubleshooting these machines or standing around them talking about it or whatever. And so what we're able to do is actually correlate directly the people that are involved in an area, working, running, moving drawings, loading, unloading, to the individual objects themselves. And we can start to get down to some serious production understanding. Like, here's a perfect example. Like, basically these pieces are sitting on the loading table all day. It's probably not, there's probably some other reasons why this is happening. But what you can see is instead of 5 pieces moving through this day, you actually have like your actual process time on these machines was very small compared to the times that these things were sitting there. And so when you talk about simulating for maximum throughput and all that, you can really go back to these core numbers about processing and then identify ways to parallelize or move the load and unload stuff, some of these activities, maybe they're quality control activities, other things like that, off of the machines and into places that allow you to get higher throughput. It really helps us to understand production better. All right. And then, some of the other things that we're bringing in are laser scanning with the drawings, looking, a lot of times we end up pouring decks. A lot of the work that we do in order to get sound and sometimes even diaphragm on the buildings, especially in the Northwest and in California, as we're still required to do gypcrete decks, being able to do those accurately and understand them. We've been able to use laser scanning and some other computer vision processes to automate those pre-pour checks so we can make sure that stuff is in exactly the right locations before we go ahead and pour. And then we're also using a lot of reality capture tools to kind of overlay what should be and what actually ends up happening. Those processes together, getting those things aligned, allow us to simulate and get insights from our scale. The other thing that we're relying on is also looking at layout in these spaces. So also having that high level of detail in those drawings gives us opportunity to do things like using spinning layout lasers. So this is an example of a tool that that we can use for quality control. We can set control. We can make sure that our objects are in precisely the right locations, but also that we can lay out walls, lay out plumbing, lay out other other tools, other assemblies on site with. And then we're also doing a lot of robotic printing. Right now up in Vancouver, we're printing on decks, all the layout for all the electrical locations, all the layout for any other installations that have to occur on the decks. And then we're doing our gypcrete, and then we're laying out on the gypcrete for walls and the rest of the construction there. So, yeah, so I'm going to actually go ahead. So I know that we're a little bit short with time today. Did I just end the share?
Still see your chart, your dashboard.
Oh, you do? You still see that my dashboard? Okay. My little control panel says that I'm not sharing, but I'll go ahead and hit the button again and try to stop. And then you'll see my smiling face.
Oh, yes. Okay.
All right. If you know, I could go into a few of those pieces a little bit more, Dylan, but you know, the biggest thing for us is that robotics does represent an opportunity for more customization. We're finding right now that the biggest challenge for us in mass timber is building a mass acceptance of the product, and some of these traditional things like still, you know, getting the supply chain working for traditional CLT and traditional glulam construction with these, you know, there's a lot of acceptance for us to move that in. And so we're really trying to make that more efficient. But at the same time, we're seeing tons of opportunities to be, you know, to increase the level of customization in that mass production and the use of, you know, with the use of robotics. Obviously, the CNC machine doesn't move up and down the floor, and it requires, you know, 200 or more feet of floor in our plant. And if we could replace that with sliding robots or other tools like that, you know, we're happy to do that and ready for that. We just also need the market to travel with us. So.
Great, thanks a lot, Aaron. It's also really interesting to see like a completely academic free approach to problem solving, but also like potentially more sophisticated in some of the in some of the algorithms maybe. But I think we've seen like a really great range, and it's fantastic to see that actually a lot of this is starting to get applied, and that it is like really moving into industry. I think if we had this conversation like even 2 or 3 years ago, it probably would have been a bit different. So I have a couple of questions that I can maybe start off with. The first is actually like I want to put you all very practical people in a slightly awkward situation, but in terms of like maybe thinking on a slightly more theoretical level, that like in Stuttgart, I mean, and the guys from Stuttgart would understand this, but Achim always uses this comparison when discussing computational design and also construction, that like sort of there is this first step which is like pure automation, and in this analogy, like he uses, of course, and I don't think this is his analogy, but he uses it a lot, that if we start like with the kind of typewriter replacing the writing by hand, this is like a sort of pure mechanical automation, and then we move to the word processor, right? And that the word processor is like a sort of step above, and we can like, it like has some more automated functionality. But then now actually we're finally reaching, if we extend this analogy, we're finally reaching with writing more generative AI approaches to this, right? Where we are maybe for the first time, like truly starting to do something different, more than just automating an existing process that we knew about. So my question is simply like, where do you think that we are in this spectrum? Where do you think that we are right now, and where do you think we can get relatively quickly in the spectrum? Like, are we still in the typewriter to the word processor, or Like, where do you think that we are?
Well, I guess I'll go first and let some of the, and then but you know, when we talk about using CLT in the residential space, like there's opportunities in traditional like stick built construction right now to be using CLT, right? It fits the the embodied carbon scenario that we look to CLT for, or that we look to mass timber for, right? In those spaces, they don't even want to have, they just want blanks. They don't even want something that is like already cut. They just want to be able to show up and literally like take a chainsaw and remove portions of these decks in order to get something through because of the lack of. So I think what we see is that the more complicated the project is, the more risk that there is with it, the more that we move toward this other thing. I think the generative AI tools are probably a much faster path to something that is really unique, but still has all of that inherent detail that's needed.
Okay, thanks. Oliver or Jakob? I mean, do you think that we are getting to the point where the computation is enabling let's say, a better architecture, even if it or a sort of different architecture than what we had before?
So I think what Aaron said is the typewriter, right? There is a slight incremental improvement, but it's fascinating, Aaron, when you say that. And I think it comes from the fact that, especially in stick frame, the on-site construction process is there's so much tribal knowledge happening sort of ad hoc that if you tried to prefabricate the panel and cut it exactly to size, it might not even fit because they did something different on site and didn't tell anyone, right? And you come there, it's like you're trying to put a race car into the Walmart parking lot. It just doesn't work that way. I think it really shows, and I'm not surprised by what you're saying, but it really shows how difficult it is to innovate in our industry, because there is such a abundance of connected there's such a network of operators that are used to a certain way of doing things, and coming in and trying to change everything is just inhibits them from doing their job, and so they resist, right? So trying to bring the entire network one level higher is just extremely difficult. And we also had to reduce our ambition. I think a very good example is the next project. Our floor cassettes were designed to implement all mechanical ducting in them, but for doing so, you have to plan the mechanical system as like at the same time as you're planning the structural system, and everyone has to be on around the same table and has to be all done at the same time. And it wasn't possible for this first project that we're doing. We had to take the mechanical system out again. It was sort of quote unquote but it got too complicated to everyone involved. And so everyone put their hands up and basically said, let's just do it the traditional way. We know how to do it. You guys are innovating enough already with the floor cassette and the envelope panel and passive house and prefab, and there's so much we have to figure out. Let's not do that. So it's really this very slow and incremental, and I think we sort of pushed a little too far basically in our first project. I would say that the analogy, actually I wanted to answer that question. We talked about also quite often, I think, about sort of the transition from manual fabrication, the pre-industrial era, where both the power that is processing the part and the information of how to process the part was with the human. Then came industrialization, and the power was transferred to the machine. The information stayed with the human. So that's the sawmills and the table saw and so on. And then you had CNC machines where power and information was retained within the machine. Yet, actually, the information still had to be made by someone, and the information that is given to the CNC machine is still human made. So for us, the next level is that the information that is given to the machine is automatically produced, and the human doesn't make the information, the human designs the programs that make the information, right? And you can go higher and higher like that. You can just always remove yourself one step further. Now you develop the algorithm that makes the CNC code, or you develop then the algorithm that makes the building design, which then generates the machine code, right? So I think that's where we are around there. It's not quite maybe generative AI in that sense, right? But it's getting to the point where you are having, implementing so much logic into your automation that you basically remove yourself almost completely from the design process, which is sort of the language generation process, right?
So Oliver is very confident that we're getting closer. Okay, Jakob, do you have a quick thought on this?
To come back at the original analogy with the typewriter, I think we're at the phase where kind of word processing was maybe in the 80s, 90s, where computers were super expensive, and some journalists might have typed their text into a computer, but it was like fairly uncomfortable. And I guess looking back now, it seems like weird that why, or back then, like people would think like, okay, I can just use my pen, it's much cheaper, right? Why do I need a computer? Or I use the typewriter that I have. I don't know. It was bought by my father, and I like to use it because I have it. And I think we're going slowly but surely, and I think in a fairly broad way to a situation also in construction where, to keep with that analogy, even if you do some quick notes, you just fling out your phone and you type in a fully digital kind of interface, right? And I think it's really true what you said. Like as soon as we're within this in this digital world, then suddenly there's like completely new aspects arriving, new possibilities that you couldn't even have thought of at the moment where you thought about, okay, let's start writing with a typewriter instead of a pen. And in that sense, I think it's going to be super exciting. I guess it's just natural that it takes some time. There's like this kind of building cultures that Oliver mentioned. And of course, there's also the machines, right? I mean, typically the hardware that construction companies invest into is like fairly expensive and needs to be paid off. And yeah, changing that every 5 years would not be feasible. I think it just takes a bit of time. But I think in some years, those technologies will definitely be also flexible enough to just accommodate like even a project-based approach. At least that's what we are working towards, right? I think the initial phase will be this kind of product platforms, as Oliver depicted them, and then the next phase is that really on a project basis, you just put together a couple of a client, some architects, some local construction firms, and then they'll be able to put together a new building design that is catered exactly to the needs of the local community, right? But is then fully automated in terms of the fabrication, or at least largely automated. And that's going to be the next step, I guess.
Okay, great. I think that is also certainly my hope in some of our work, but also that it is potentially considering fiber sourcing. So the sort of place-based approach is not just about people, but also about the environment and the sort of resources that available in each environment. So I think this is also, again, a really nice range. And I think it also highlights maybe that with mass timber, of course, we have, like, I think Oliver, you explained, Oliver, you explained, and Jakob has many times explained the kind of like big challenge that we face in building construction. And of course, we will need like a sort of diverse range of solutions to tackle this, which may have actually wildly different approaches. And so I think with all three of you, we see they might seem similar, but I think different approaches and products, and it will really be a sort of system of systems of ways to tackle this problem. I have many more questions, but I wanted to ask maybe if Ian or Judith, you have also a question that you want to pose to the group.
Not from me, Dylan. Go ahead.
Dylan, I have a question, right?
Go ahead.
Hi. One of the things that we've been hearing a lot about in our tours through the mass timber ecosystem in the Pacific Northwest is we hear from manufacturers of panels that what they're really interested in is having big orders of standard panels, like they can just churn out the same panel over and over. And yet, you know, the promise of automation is mass customization. And I'm just wondering what you think about that, whether those ideas are compatible, you know, in certain ways, or, you know, the industry can handle both, whether they actually merge, converge, go in opposite directions. Anyway, I'd love to hear your thoughts about that.
Thanks, Judith. This is a very timely question. And yeah.
Yeah, I think it's totally compatible. It's just that the technology doesn't exist yet, right? There is not yet a building system that is really independent of, let's say, really most of the boundary conditions. As soon as you start from a CLT plate, you still have certain kind of economics that play into cutting a certain angle off, right, or cutting a shape into it, into milling more elaborate or less elaborate joints into it. But I think that's definitely possible also with timber to build kind of highly automated building parts, and for that matter also building structures that are completely adaptive to the design that you chose, right? And overcoming this kind of economics that we know from CLT at the moment, where it's most economic to build a panel that is exactly the size of the transportation truck, right? And that's of course like a logic that is kind of then becoming very constraining. But I think we'll get to a point where it's more or less almost as in 3D printing, where the 3D printer really doesn't care what shape you want to print, right? And that just will take a bit of time. I think we're at the very start of those systems, especially in multi-story structures. I think you might find similar things actually more in special structures already. I think for steel space frames, that's almost like existing already, as an example. But for mass timber multi-story structures, I think that's coming up, or at least we're working on it.
It'll be coming up if you continue to work on it. Yeah.
Well, and there's also a lot of the other, you know, a lot of this has to do with when you're purchasing equipment and doing that. I mean, there's a few layup beds, and you want to buy automated equipment, and there's a couple of like presses, and there's a few microwave curing tools and things like that. And those things are expensive, and you want to keep them occupied and doing that kind of work as much as possible. And the economics of robotics are being made a little bit more possible through like reconditioned machines that are coming out of the automotive industry or things like that. But it can cost you as much to set up a single robot with equipment as it does to set up a CNC machine. And then, you know, the reality is you can get more throughput and speed with a 600-watt spindle than you can with the spindles that fit on most robot sizes. And then you've got other issues with other kinds of actuators and shifting actuators and needing multiple robots. So I think for us, a lot of it is just like we know we could set up a factory today. And then the other thing is that you've also got 15-year depreciation on this thing. So you spend $50 million on a plant, and you've got 15 years to depreciate it, and you're in a rush.
Yeah, I think it's not so much about which equipment it is. You know, if you process 40-foot long panels, then you need a different machine than a robot. I think that's absolutely clear. And CNC machines exist for different size components. We constrain ourselves to smaller parts so that we have an easier time machining them, and then we put them back together into larger parts that then are truck sized. And from that moment on, basically all automation is out the window, because you just need tools that can lift, 5 to 10,000 pounds. And that's just massive stuff, which is also a lesson in automation, I think, is moving things around that weigh more than 1,000 pounds is actually really, really difficult and dangerous. I have a slightly different opinion, though. I don't think, Judith, you're asking the right question, because I think, and at least in our opinion, a CLT supplier is like a supplier of rolls of steel in car manufacturing. They will not prefabricate the building unless they choose to and want to. And if you want to combine it, be a CLT manufacturer and be a prefab company, then you can do so. I mean, we are also combining manufacturing with systems design and engineering. But CLT is a raw material, like steel, rolled steel. And you take that and you make prefabricated components from it. It is not the prefabricated component. It is just a single material. And so it is true that these suppliers, just as the rolled steel suppliers, want output more than anything, and standardized output ideally, so they can achieve high output rates. And that's what we are hearing from every CLT supplier. CNC machining is the bottleneck. If they can supply standard stock material to us, they are more than happy to do so and give us a discount on top of that, because it guarantees them the output, and it guarantees them they can stay away from their CNC machines, and the press becomes the bottleneck and not the CNC machine. And so just like, again, in the car factory, the car manufacturer is pressing the sheet metal, we are machining the parts just in time. And so we are building the machining capacity to keep up with our production of prefabricated components, which is slower likely than what the CLT manufacturer outputs in terms of volume. And so I think then it makes sense.
Okay, thank you. Thank you all.
Great. I think that was a really, really good question. I think if maybe one last, can we continue a few more minutes, or do you think we should? I'm happy to continue.
I think it's fine if others are, as long as people are sticking around, and it's a really interesting discussion. Yeah, go for it.
Okay. I mean, I have maybe slightly similar question to Judith, but like, how do you see? So it's really interesting to me that now these two approaches, Aaron, I don't know if you have an architecture training, but that at least with Jakob and all of you, that these sort of approaches are coming a little bit more from the architectural side, and then sort of filtering down and trying to connect back into the sort of fiber supply and traditional wood manufacturing points. And I think with TimberLab, this has somehow been similar, Aaron, that like Swinerton is a general contractor, not a ULM manufacturer. And I'm interested, like, how you see also that connection, like, into the ecosystem of like wood materials and products, and that, or is it even semi-finished products? And then like also on the other end, like where you see the connection into the kind of general contractor construction on-site stuff, and where you sort of position there.
Well, for us, a lot of this is about competition, right? Like we're like, even if we were the best at this, we're not gonna get all those high-end projects, right? We have to go to scale, and we have to figure out how to do that. And so we started really looking at markets, right? And there's a lot of opportunities in these 8 to 12 story housing scenarios. There's a lot of opportunities in those spaces. Those spaces typically are looking for the most cost-effective solution. And so the scalability, the standardization, all of that of the parts becomes a big opportunity, right? I think our biggest challenge in the business is like, so I guess the point is like they're all driving each other. The architecture and design is being driven by the client's needs, right? And if the client's needs are like a certain amount of square footage and a circulation program and like double loaded corridors because it's what makes the thing work, then you've got, you know, a grid associated with that. You've got a program associated with it. You've got all these things, and you know, we can go in and you know, take something that is already relatively proven and move the mass and substitute in for mass timber, sort of unsolicited, step into the situation and convince everybody to shift over. But I think you know, I think there's also these opportunities with really tall buildings and other spaces like that, but it's just really about the market for it. Like we love these ideas of like of metal-less or like metal connectorless buildings and those types of things, right? But they also add a lot of uncertainty and a lot of and we need to prove them for a long time. It's much harder to make that sell when there's already this sort of, you know, 3% price premium and these other transversality constraints with risk and stuff. And even the architects are on board with those risk conversations.
How about you, Oliver? Like, so maybe on the other end, I mean, you guys are coming from the point of architecture, but then, I mean, do you guys have ambition to one day also own a lamella planing factory like Timberlab has just acquired, to complete the vertical, and then maybe a forest to complete the vertical cycle? Or do you think there's enough to do in your your quadrant?
I can only give you a pro and a con argument. The pro argument is obviously that vertically integrating your company from, let's say, forest management to general contractor and maybe also operating buildings, obviously reduces or combines your profit margins. It in theory makes you more profitable business, gives you more control, and so you can really own the entire supply chain, which also makes it easier to design the buildings correctly according to the constraints and possibilities that you can offer in your system. The con argument is that the more you vertically integrate, especially in construction, the more you are susceptible to changes in the economy. So every plant that you build along the supply chain has a minimum output capacity that makes it a profitable business, and those vary widely from, you know, from forest management to sawmills to CLT production to building component manufacturing to what a GC needs to do. And so you will then need the highest of those values will become your minimum throughput. And so that makes you very susceptible to you know, the ups and downs that we are seeing in the economy. So actually a distributed supply chain, a distributed ecosystem of suppliers is in theory more adaptable to these changes. And so I think it is, I mean, I think it's all very theoretical, because ultimately what we need is simply that the entire industry upskills and implements more technology so that we can build an ecosystem of suppliers, such as, you know, what Aaron mentioned. There's just not enough industry there to even make CLT supply reliable at this point. It is
Yeah.
still a little more risky. It's still a little bit more, different, and so it has these hurdles, right? And that's ultimately, I think, it all comes together from an architecture perspective. You need architects that understand and appreciate systems design or systems building, and who understand the advantages when using systems, and who understands that there are constraints compared to the traditional process. And in some ways, the architects, at this point at least, are mostly trained to make custom buildings. They're not trained to be a systems integrator. And so they are actually working against that. And there are obviously many firms and many architects who would like to work with this, who see the potential. But we have to be very clear about that when we enter a project, that it is extremely important to follow the design rules that the systems have, and to understand them and to work within them. Otherwise, you just work against the process and you make the project more difficult, basically, than a traditional project.
Yeah, I agree. I agree with that, Oliver, 100%. Like, our biggest challenge is lumpy demand, right? Is the ups and downs in demand. But one of the things that we're confident about is that the market itself for these materials like CLT is so immature, and there's so much upside, that we're not going to be the only supplier. We're not going to only buy from ourselves. We're not only going to sell to ourselves. And so that's why the TimberLab entity being really separate and operating in a different way is like, it's got its own market, it's got its own direction. But that's a very important consideration here.
Yeah. I do have to head out though, unfortunately.
Okay, great. Jakob, did you want to say something quickly about this?
I think in Europe there is certain companies that do this kind of integration of basically traditional foresting sawmills that became now CLT manufacturers as well, and that start now to really offer kind of their own building systems. Funnily enough, Dylan, there is also the Vigro companies has their own timber building system now based on Paulownia trees.
Yeah, well, I guess like in the most progressive society, the forest would end the company. That would be the next level.
In the most transformative society, the money supply would be connected to the growth of forests, I would say.
Yeah.
That's a very different discussion, though. No, what I wanted to say is I agree though 100% with Oliver's statement. I think the current construction company industry is all the survivors of ups and downs, right? And the idea of systematizing and integrating vertically is not so fundamentally new, right? People tried that 100 years ago, and somehow none of them really survived so far. And that's really something to I guess take some time and ponder upon. And that's also what makes me believe that what we really need is not the reorganization of the industry, but rather a faster, easier, and more flexible automation integration process, right? So that if two construction companies decide they want to split the work on a big construction project because it's just too risky for one of the companies, right? That they can actually figure out how to plug in both of their kind of factories or both of their kind of prefabrication facilities in an efficient manner, right? And then that production is going to run for a couple of months, and then the automation needs to kind of be reinvented, right? And currently that process of kind of reconfiguring automation process is of course like much too cumbersome to really do that on the market at the moment, right? But with the progress in the digital tools of commissioning those processes and designing those processes and plugging them together, I believe that we're gonna get there, and then automation really becomes feasible in construction without reorganizing the whole industry landscape, right? And I think that's just fundamentally a different technology than what we see currently in manufacturing. There is no like kind of role model, but that's some process that the construction industry really needs to kind of invent and develop for itself. But I think that's going to happen.
Yeah, I think the idea that the verticalization results in economies of scale today is dead. But I also think that we need to get the cost of mass timber construction at parity with the cost of steel and concrete. And as long as those environmental factors are not internal to the economics of it, if those externalities become internalities, then that cost premium will go away. But we've really felt like that's the key, that's the value creation component of it. This isn't a traditional verticalized opportunity. This is about value creation today, and we got to lower the cost of these fundamental materials.
Totally agreed.
Okay, great. I think Oliver had to take off, so I think we should quickly wrap up. Thanks, Jakob and Aaron and Oliver, for a really fantastic presentation. And I think the start of maybe a much longer discussion. It was really great to have you guys join, and it's awesome that we can do this in over Zoom. I hope that we can, of course, also at some point meet in person as well, and that we can have you guys together, perhaps at the International Mass Timber Conference, to continue these discussions. Ian, do you want to say anything to wrap it up or introduce the next meeting?
I don't want to other than just to thank the presenters again. You know, Aaron, Hans Jakob, thanks very much. That was really, really interesting. And thanks, Dylan, for putting this all together. And thanks, Parker, for promoting it. And I'm not sure what we have for the next month. I don't know if we have that nailed down yet, but we'll be in touch and post that in the coming weeks.
Yeah. Thanks, everyone. It was really, really super interesting. Thank you. And thank you for staying up till what is almost 3 a.m, I think, for you. That's Jakob.
2. Yeah, it's almost 2.
Yeah.
All right,
No,
thanks a lot, guys. And thanks to everyone that joined.
Thanks for the invitation. Yeah, I really like the exchange across the Atlantic. I think that's something that we should keep going.
Yes. If not, we will see you, I guess, in Australia.
Right.
Oh, thanks for having me. And
Thanks a lot.
thanks for the
Right.
Thank you.
Thank you.